So what I thought I'd do is complete the trio of comparisons to the Fluke 1587 and compare it to the MetraHit Coil that I'd previously compared to the MTR 105. And we'll start off with prices, I think. For the MetraHit Coil there on the left, the package, which is what you see in front of you, which includes the meter there, the set of leads and the coil test adapter on the left. That'll set you back £880 in the UK recommended retail price. Fluke there, 1587 FC, you've seen it in the other videos. You get the hard case with it, quite a nice sturdy hard case. You get the remote probe that sits in front here, 2 crop clips, thermocouple, set of GS38 probes and the leads with it, and that will set you back £785 recommended retail price. Now, as I said in the other video, there was a lot of offers around there for the Fluke 1587 FC within the UK, and I've seen it as low as £450 if you're lucky, so that's quite a bargain at that price. In contrast, the MetraHit Coil there, I actually got that from Germany. Very, very difficult to get within the UK and pretty difficult to get anywhere in Europe really. So it usually keeps its retail price up, and they're very rare to get a deal on that. Obviously it's substantially more and it's missing a fair few of the items in comparison to the Fluke there. Those items are available as optional extras. You can get a case and you can get crocodile clips and you can get a thermocouple there for it, and that lot will set you back around about another £100 to get those items. Again, adds a bit more to the cost. And there is more to come that we'll get into a little bit later. Okay, so let's take a closer look at the probe arrangement for the leads. So we've seen the leads for the Fluke before. They come with these GS38 caps that are removable. Leaves you with a standard 4mm adapter that will go into the chosen accessory, but obviously with the leads being normal 4mm, you can put them straight onto the lead as well. Access to terminal wise, 35mm we're fine, and we can get into 4mm and just about 2.5 with the cap off. With the cap on, it's only the 35mm that's available. 6mm, that one is there, which is available to me. 4mm is not, can't make contact there. 2.5 is definitely out as well. For the Gossen Metrawatt, a similar sort of approach really that you get with these leads. And I'll go into the 35, 4mm no, 2.5 no chance, 6mm. Oh yeah, you can just get in on 6mm there. These caps are a bit of a pain. They have to prise this tab out to get the cap off, and you actually see if I can get close enough. Sure, around here where it clips on, you can see it's actually beating up the lip that it clips over. They are very, very tight and awkward to get off without the use of a screwdriver, which obviously is going to add to the annoyance factor. But once they're off, same as the Fluke, you can get in to the 2.5s, no problems. 4mm, 6 obviously no problem. And with these being moulded on the end here, the accessory has to go onto the lead. That's the only way you can do it with using the Gossen Metrawatt leads. It's not my favourite approach. It does tend to put a fair bit more weight on the connection. If you are on threads, it's not too bad, but on flatter surfaces, sometimes they can come flying off when you've got that kind of arrangement. As I say, they don't actually arrive with the meter itself. You have to buy them as extra. We get the thermocouple, standard Fluke thermocouple that you get with it. Nothing that you get with the MetraHit Coil, even though it does have a temperature facility on the instrument. And the remote probe is the final one you get with the Fluke. Again, you don't get this with the MetraHit Coil, but the MetraHit Coil isn't capable of working with a remote probe. It doesn't have that feature at all. So if you like this kind of system for going down terminal rails, testing terminal rails, you can't do that with the MetraHit Coil. So that's the leads all done. We'll flip around and we'll take a closer look at the actual instruments themselves. Okay, so for the actual instruments themselves, both of them have a moulded rubber cover. That's fairly tight on this one. You have to take the cover off to gain access to the battery and fuse compartment, which is just on that one slotted screw there. To open the case up for Gossen Metrawatt, it's a much softer cover, comes out of it extremely easy. The cover itself, on both of them you have the probe holders here for storage and for holding it for one-handed testing if you want to, and you have the T-Pack magnet strap that can go into the Fluke on Gossen Metrawatt. Again, you've got the probe holders for storage. You have this wire loop that you can pull out and hang them on a nail or a screw or something like that. The other thing that I've noticed with this as well, I'm not sure how well I can get this in or display this, the hinge for the tilt stand is part of the rubber of the boot, whereas this is an actual hinge pin that clips into the actual case, and the stand is hard plastic. So I'm not sure what the longevity of that will be, whether it will tear or not. Yeah, don't know. On the back of the case you have separate compartments for the fuse and another compartment for the battery pack there, which is 2 AAs on this. When you put them into the rubber boot, you can actually gain access to the fuse compartment here whilst it's in the boot, but you can't for the batteries, which for me is the wrong way around. I would have wanted to get to the batteries more often than I do the fuse, but there you go. One extra additional bit to the Gossen Metrawatt is you can power this from a mains adapter, which you can't do with the Fluke. So if you're doing some long-term logging, you've got that option there to save on battery power. And that PSU does not come as part of the kit, but it is an optional extra at a cost of £143. With regard to the actual instrument operations and functions, we've got volts AC on this. In a similar manner, this is a soft start on the button there, and the actual switch just controls the functions. There's no on-off position on this switch. So AC volts, you've got AC volts as well, and this has low pass filter. This also has a low pass filter, but you have to access it via the menus, which you go through here, which gives you your hertz, which you can also have on the 1587 there. You then go through duty factor there, which I don't think this has. No, I don't believe that has duty factor. This does. And then finally there's your filter there for true RMS reading. Next one round is volts DC. Volts DC on this one as well, so both of them have a separated function, which is my preference for these kind of meters. I don't like the auto AC/DC functions as much as I do having a separate selector to them. This one then will move around to millivolts and temperature as well. This has a similar millivolts range. It actually measures from 10 microvolts to 1000 volts, which is a little bit better. This is 100 microvolts, so has a slightly better DC range, and it's all on the one function. You don't have to switch to millivolts. Next one round is ohms. You have ohms on there as well. On here you have capacitance for this function, and this is a separate function actually mixed in with the temperature that was over here on the millivolts. To flip between the two, you just use the function button here, and it can tell you it can do a type K or a PT 100. So I go back one, you then move on to continuity, and this is on continuity, and also has a diode function. I'm not sure if this also has a diode function as well. So they've both got that facility there. So for the Gossen Metrawatt, I should have pointed this out earlier, you've got the main function up here, and then you've got the alternative function on this side of the switch that you select with the function button up there. Flipping one round, you go to milliamps, you get the warning to say you've moved to the current function, AC/DC milliamps. It's off the jacks there, up to 440 milliamps. And for the Gossen Metrawatt, I'll keep it here, you see there's a red cover over the milliamp jack here. As soon as I flip this around to amps DC, it flips over and it blocks off the voltage and opens the milliamp input jack there. And we're on separate functions for DC amps and AC amps there. And this will actually go up to 10 amps on AC and DC against the 400 milliamps of the Fluke there. It goes down to 100 nanoamps. Okay, flipping back, we go to the insulation test function. Just flip around here on the Fluke. Again, it warned me about the lead. Electronic selection of the test voltage there, 50 all up to 1000 volts through 5 ranges. You can also, not sure how well you'll see it on this one. It's very small. It's actually up here. I'll bring it closer, and hopefully you can see it operating there. And you can select the voltages there, 50. So same voltage selection. We have dar and pi ratios on this, and also time, so you can actually lock this on. The MetraHit does not have dar and pi ratios, and there is no way to actually lock the insulation test on. You literally have to keep your finger on the button for as long as the test you want, and then let it go. What this instrument does as well, whereas these instruments will actually display the value of the insulation resistance at the end of the test when you let the button go, this flicks straight back to voltage, so you lose it, which isn't a very nice, helpful feature really. I'd much rather the insulation value stayed on the screen for you to write down. So for insulation testing range, this will go up to 2.2 gigaohms at 1000 volts, but then drops off 550 mega ohms on the 500 volt setting and keeps going lower. This is 310 mega ohms at 50 volts. All the other ranges, 100 through to 1000 volts, are 3.1 gigaohms. So it does have a higher test insulation value capability than the Fluke, but to my mind, with the rest of the stuff that's going on, with the way it operates, I'd sooner have test capabilities of this rather than the higher test range. But that's just my opinion, of course. Now, what is unique to this instrument that this little fellow does not have is this Coil interturn fault tester. And you use this on the insulation test function, except you use the function switch to switch to the Coil test, which is actually this one on the insulation test, and it plugs in. I've got some of the videos that show this being used, and then you plug standard leads into here and connect them onto your motor, and then you can test away. And it gives you the reading again, and again you see it flicks back to voltage and discharges. So even with this test as well, you've got to try and remember the actual value before you stop the test. In regards to the functionality of this, again it's on the other videos, I've found this to have very erratic behaviour. I've emailed Gossen Metrawatt asking them for a different adapter, giving them all my motor details. I've even asked them about being able to lock the insulation test on. Gossen Metrawatt do not appear to want to talk to me, so I am none the wiser. So in the end I got that fed up with it. I built my own little test adapter up, that it solves, I guess, a good 90% of the issues I had with getting readings, but there are still a few motors out there that I can't get a stable reading on. And obviously this doesn't solve not being able to lock the tester on. We could show the backlights off. This has got quite a nice backlight on it actually, and the display is quite clear. You do in certain areas fall down with very, very small lettering that you don't have that issue with on the Fluke. I doubt you can see the Fluke screen, or you can see it a bit. Quite a poor backlight on this. It's okay if it's in the dark, you know, it's adequate. But the display on this I do find to be quite a bit nicer. You've got the analog graph up there as well, if you like that kind of thing. Okay, so recording of data. No internal memory on this one whatsoever. Everything you record has to go through Fluke Connect, which it's built into this unit to connect wirelessly to an iPad. Fluke Connect basic version is freely available for you to download and install. If you want extra, then you can pay for a subscription service. But the basic test, which covers most of my needs to be honest, is free on the Fluke Gossen Metrawatt. I hope you've got a bit more money left, because this will transmit data as well, and it will also have its own internal memory for data logging. You can see the main function button there, and you can set up a record value on this to record internal data. However, if you want to get it off, it's an external adapter, IR adapter, that plugs in there. That will set you back another £230-ish. That plugs into a USB Windows only computer, and the software will set you back around about £210. So that's an awful lot of money you need to add to this to bring it up to the same kind of testing capability over the Fluke. Okay, I'll shove the instruments over to the left there, and hopefully I can get the table of accuracy test results up on the right hand side, and we can work our way through them. Not much of a difference really between on the voltage readings, AC and DC linearity, fairly consistent between the two instruments. So measuring AC current, AC quite a bit better accuracy on AC current with the MetraHit coil. That's actually measuring 0 to 10 amps direct on this input, and 0 to 10 amps through a clamp adapter on the Fluke. If you flip it over to DC, you actually get a better response from 1587 than you do the MetraHit there. And said all that, with the real world application of a transducer output test, both instruments were spot on. Nothing to choose between them. Resistance, again, not much to choose between them really, as is capacitance, not an awful lot there. And then we move on to some quite interesting results with the insulation testing function. Open circuit volts test, better for the MetraHit coil, but the IC standard is a 20% tolerance, so nothing to worry about there with those results. Short circuit spread and 1 milliamp load current. There is a massive problem with this MetraHit coil, which again, Gossen Metrawatt don't want to talk to me about. But you see, I'll put the actual results up for the tests, and you see on the 1000 volt scale, this cannot produce a 1 milliamp load. As a consequence, you get a huge spread on the short circuit currents, and you don't get the 1 milliamp test functioning, which is quite surprising because that is a requirement of the IC standard. So this instrument at 1000 volts insulation test does not pass the IC test requirements. It does pass it on all the other ranges, whereas the Fluke passes it on all the test voltages, including the 1000 volts. For the actual voltage regulation, 500 volt test this, not much to choose between the instruments really, fairly happy with that. And then we go to the winding simulator and measuring the phase resistance as a practical test, and you get much better results from the resistance readings of this instrument than I do from that one. You've got quite a bit better resolution on this instrument as opposed to the Fluke here. I don't know why I did that, because they're both on overload, aren't they? However, both of these are 1 milliamp test current. Neither has the 200 milliamp test current. Again, that's another requirement of my country for continuity testing, to have a 200 milliamp test current. So with those poor results on the current regulation of this unit, you actually end up with an overall accuracy of 13% for this one, just under 2.5 for the Fluke, so Fluke trumps it quite a bit there really. Okay, so decision time with these two instruments. So for me, unfortunately, with all the issues that I have surrounding the MetraHit Coil, with regard to how it does an insulation test, the lack of accessories that arrive with it, given the overall total cost, I find it very hard to justify purchasing that instrument over a Fluke 1587 FC. The only thing that the MetraHit really brings to you is this inter-turn coil test that is unique to that instrument. I've not seen any other instruments come out with that at this moment in time, but as I said, it is unstable and I've had to develop my own adapter in order to give it some stability, which has improved it but not solved it 100%. So unless you have a specific need for testing inter-turn faults, I would plumb for this 1587 every single time. So that's pretty much it for this video. Hope you found it useful. Thanks for watching, and I'll see you again in another video.